Hello, welcome to the last kind of series of lectures on stereochemistry. This should wrap up our stereochemistry unit pretty nicely. We're going to talk about naming stereocenters. So when we have a set of two enantiomers, right, we want to be able to call them different things, right? So we'll do an example of this here in a minute, but if you have something like 2-bromobutane or something like that, 2-bromobutane has two enantiomers. So we need to be able to say, is it this particular enantiomer of 2-bromobutane or is it the other one? Right? And so we'll go over how to name that. We'll do some examples of it, and that'll wrap up this video. All right. So when we're naming stereocenters, we're going to name them as either right or left-handed. So remember the example, your hands, of course, are chiral. We did this I did this example kind of a little bit in a previous video where your hands are mirror images of each other, right? And so you have one right hand and one left hand. Hopefully that's true. Um, from there, right, so molecules we're going to treat the same way. So molecules will either, or stereocenters will either be right-handed or left-handed. And so how we figure that out is what we're going to talk about. So stereocenters will either be R, right, for right-handed, or S, which stands for sinister, which is the Latin word for left-handed. So if you're a left-handed person, then you are by definition a sinister person, which is kind of fun. But yeah, so we're going to name each stereocenter as either being R or S. And so remember that every stereocenter, we'll write down this definition one more time. Every stereocenter is an sp3 carbon with 4 different groups attached. And so what we're going to do is we're going to number those 4 different groups, because in every situation we'll always have 4 different groups. We're going to number those groups, we're going to assign them priority, and then depending on what direction they're oriented around that stereocenter, we'll assign it as either right-handed or left-handed. So the first step is, step 1, is to assign groups priority numbers. Okay? And we're going to do this by atomic number. Right, so if you have a periodic table, you can find the atomic number of everything. And basically what this tells you is oxygen is a higher priority atom than carbon. Bromine is a higher priority number than chlorine. Chlorine is a higher priority number than oxygen, et cetera, et cetera. Right, so if we have a stereocenter, I'm just going to do a really quick example of a stereocenter. I'm going to do a stereocenter that has a bromine, a fluorine, uh, an oxygen, and a carbon. Right. So this here is our stereocenter. It's an sp3 carbon. It's got 4 different groups attached. This carbon right here in the middle is our stereocenter. The first thing we're going to do is assign each of those 4 different groups a priority number. So we look and we say bromine, there's a bromine attached to this carbon, there's a fluorine, there's an oxygen, and there's a carbon. So the highest atomic number of those 4, bromine, fluorine, oxygen, or carbon, is obviously bromine. So that one is priority number 1. Right. The next highest would be fluorine. And I'm just looking at a periodic table to figure these out, right? There's nothing, we're just looking at atomic number. Next up is oxygen, 3, and then the carbon over here will be the lowest priority group. So that'll be group 4. So the first thing we do is assign all of the priority numbers to the 4 groups that are surrounding our stereocenter. Now, the important thing here is you will always have 4 groups, right? So what happens if, I don't know, let's say that you are looking at something like this and you want to assign priority numbers at this carbon here. Now the problem here is you have an oxygen, and a carbon. You only have 3 groups connected to this carbon, and so you can't assign 4 different groups. And the reason you can't do that is this is not a stereocenter. Right? Remember that stereocenters have to be sp3 hybridized. And so in this case, the carbon that I indicated here is sp2 hybridized. This cannot be a stereocenter. So if you go to assign your priority numbers and you only have 3 groups attached to that carbon, guess what? You don't have a stereocenter there, right? So you can't assign priority numbers that way. All right, the second thing we're going to do, so once we assign groups by priority numbers, the second thing is we find group 4, right? So we're going to base everything off of group 4. So in this case, group 4 is the methyl group. And then there's two options. One in scenario A, right? Group 4 is oriented back, or it has a hashed bond, right? Now that's not the case here, right? Group 4 in this case has a straight line bond off to the left side. So fluorine is the group that's oriented back. So we're not in scenario A this time, okay? If it was, so we'll draw the well, nope, you know what? We're just going to keep going with this. The other option is, of course, scenario B, right? And that's where group 4 is not oriented back. And that's the one that we're in here, right? If group 4 is not oriented back, what we have to do is we have to switch group 4 with the group pointed back. Right? So we would redraw this molecule, and I'm going to put the bromine here. I'm going to switch the CH3 and the fluorine. And then I'm going to redraw in all my priority numbers. All the priority numbers stay the same because they're the same atoms, right? 1, 2, 3, and 4. And just going by atomic number, bromine is still the highest, etc., etc., right? Now, this is our original. What is this compound? What is the relationship of this new compound that we just drew compared to our original? It is the enantiomer, right? Because if we remember our enantiomer lecture that we talked about before, if we switch any two groups on our stereocenter, we create the enantiomer, right? So once we've switched those two groups, now we've drawn the enantiomer, and then we look at if we go from one draw arrow from 1 to 2 to 3. Okay? So on the enantiomer, we're going to go 1, 2, 3, right? If this is clockwise, right, then we've got the stereocenter that I just drew here, right? The stereocenter of our enantiomer is R. If it's counterclockwise, or if you're British, anti-clockwise, right? If it's counterclockwise, then the stereocenter of the enantiomer is S. Okay, so depending on which way, so this one we're going counterclockwise, so this stereocenter here is S. Okay? This is actually the same thing that happens in scenario A. Where's my thing? Right, so in scenario A, we draw arrows from 1 to 2 to 3, and then again here clockwise equals R, counterclockwise equals S. So you're just starting your arrow at 1 and drawing the arrows all the way around to get to 3, right? And in this case, it's going counterclockwise, and so this would be S. Now, if the enantiomer is S, what does that mean about our original, right? If the enantiomer is left-handed, then the mirror image of it has to be right-handed. So that means our original is R. Now you have to be careful. You can't, because this only works if group 4 is in the hashed bond position, right? If you draw your arrows going 1, 2, 3 in this case, sometimes it will work and sometimes it won't. And so you can't, if group 4 is not in the dashed bond position, you can't just go draw your arrows and say clockwise is R, counterclockwise is S. You have to draw the enantiomer where the group 4 is in the back position, figure out the orientation of your enantiomer, and then know that the original is the opposite. right? So if your group 4 is not oriented back, you end up having to do extra work. Okay, so I'm going to stop this video here. There's some examples I'm going to do in the next video that will just kind of walk through a bunch of examples, talk about priority numbers and all that kind of stuff. So you'll get to see some of these problems get actually worked, which I think will help because doing this kind of abstractly is tough to see. So hopefully that makes sense. If you have questions, of course, never hesitate to ask. But check out the next video. We'll actually use these rules and do R and S on some stereo centers in the next video. See you there.